Let's continue chapter 4, chemical equation and stoichiometry. 4.2 Stoichiometry. Part 2, third hours. 4.2 Stoichiometry. Learning outcome at the end of this topic, students should be able to learning outcome A, learning outcome B, already discussed last lesson. So today we continue with learning outcome C, perform calculations involving limiting reactant and percentage yield. First example. For the following reaction, 2 ammonia react with 3 copper 2 oxide to produce nitrogen gas, 3 copper and 3 water. Given here, 18 gram ammonia and 19 gram copper 2 oxide are allowed to react. Also given, relative atomic mass copper equals to 63.6, hydrogen 1.0, nitrogen 14, and oxygen 16. The questions are: first, determine the limiting reactant. Second, calculate the mass of nitrogen gas formed. C. Determine the mass of the excess reactant after the completion of the reaction. Solution. Determine the limiting reactant. So how we determine limiting reactant? So previous lesson we already discussed 4 steps to determine limiting reactant. First step, write complete equation. So here, 2 ammonia and 3 copper 2 oxide to produce nitrogen gas, 3 copper and 3 H2O. This equation already balanced. Before we proceed the next step, please make sure equation already balanced. Second step, calculate mole present of reactants A and B. So mole ammonia. So you can set A may be ammonia and B may be you set copper 2 oxide or vice versa. So here we set A as ammonia and B as copper 2 oxide. So now we want to determine mole present of ammonia and mole present of copper 2 oxide. So how we determine the number of mole? Formula is mass ammonia divided by molar mass of ammonia. 18 gram ammonia divided by 17 gram per mole ammonia. So how we get 18 gram? These are from equation given. So the answer is 1.059 mole ammonia present. So how about mole copper dioxide? 90 gram divided by molar mass copper dioxide 79.6 gram per mole. 90 gram mass copper dioxide already given. So the answer is 1.131 mole. Next, calculate amount of reactant B required to react completely with reactant A. According to this equation, we can write stoichiometry equation. So first, you write from equation 2 mole ammonia equivalent 3 mole copper dioxide. So here we set ammonia as A and we set here copper dioxide as B. Actually, step 3, we want to calculate amount of reactant B required to react completely with reactant A. So B here, this is a copper dioxide, and A here, this is a ammonia. If 1.059 mole ammonia react equivalent with what mole of copper dioxide required? 1.059 multiply with 3 mole copper dioxide divided by 2 mole ammonia. The answer is 1.5885 mole copper dioxide required. And you see here at the left side is the ammonia, and right side here this is a copper dioxide. So how we get 1.059 mole ammonia? This is actually mole ammonia present from the step 2. So that we compare copper dioxide present and copper dioxide required. So copper dioxide present, this come from step 2. 1.131 mole copper dioxide and 1.5885 mole copper dioxide required. So actually this is less than mole copper dioxide present less than mole copper dioxide required. So that CuO or copper dioxide is the limiting reactant. Next, calculate the mass of nitrogen gas formed. Actually, limiting reactant limits the amount of product formed. This equation, how to write stoichiometry equation? So first, you need to write from equation. 3 mole CuO copper dioxide equivalent with 1 mole nitrogen gas. So at the left hand side, we write 3 mole CuO, copper dioxide. And at the right hand side, we write 1 mole nitrogen gas. 3 mole and 1 mole nitrogen gas, this come from equation. If 1.13 mole copper dioxide, so what mole of nitrogen gas? 1.131 mole copper dioxide multiplied with 1 mole nitrogen gas divided by 3 mole copper dioxide. So the answer is 0.377 mole nitrogen gas. Please remember, when we write stoichiometry equation, always need to compare with limiting reactant. If we want to calculate product form, always refer to limiting reactant, because limiting reactant will limit amount of product form. So how about mass? Mass of nitrogen gas form 0.377 mole nitrogen gas times with molar mass nitrogen gas 28 gram per mole. So the answer is 10.56 gram. Next, determine the mass of excess reactant remain after the completion of the reaction. Only the limiting reactant is completely consumed. Always remember. Okay, this is the equation. So you just write from equation. So how we determine mass excess remain? So you write 3 mole CuO copper dioxide equivalent with 2 mole ammonia, because ammonia is excess reactant. So excess reactant you write at the right hand side. If 1.131 mole copper dioxide, so what the mole of ammonia? So the answer is 0.754 mole of ammonia. So this is a mole of ammonia reacted. So what is the mass of ammonia in excess? So mass. Now we calculate mass of ammonia reacted equal to 0.754 mole times with 70 gram per mole. So mass of ammonia reacted 12.818 gram. So how about mass of ammonia in excess? 18 gram. So this is a mass present minus with mass ammonia reacted. So we get mass of ammonia in excess. So the answer is 5.182 gram. Thank you.